Now let's deal with the situation where when you solve your initial value problem, there is a discontinuity in the function that you find. The reason why that's a problem is because if you're finding this derivative must be a continuous function. Because differentiability implies continuity, then we can't say that a derivative exists when it's not continuous, when the original doesn't exist even. There's no value. So we're going to make sure that we restrict our domain of the original function to just include a continuous piece of that function. So we're going to do the same thing. We're still going to integrate both sides. The integral of dy dx is still y. That hasn't changed. The integral of 2x is x squared, and the integral of secant squared is tangent of x, and then we're going to include the plus c. So now if you notice, this equation is going to have some discontinuities in it because tangent includes some asymptotes. So before we deal with that, though, let's just find the c. So I'm going to plug 3 in for y, 0 in for x. Hopefully you remember what the tangent of 0 is. Okay, so tangent of 0 is 0. So these just cancel out, and you end up with 3 equals c. So now we know that our original equation is y equals x squared minus the tangent of x plus 3. However, this equation includes, it looks like one big thing, this equation includes some discontinuities. So the only piece of this equation that's going to provide any problem make something that, provide an issue where the domain isn't all real numbers is just this tangent piece of it. So if you just, like on the side, kind of think about what tangent looks like. It kind of looks like this with these asymptotes at pi over 2, and then every pi away from pi over 2. So at pi over 2, at 3 pi over 2, negative pi over 2, and so on. So you need to pick. Your goal in finding the domain isn't to tell what numbers you can't plug in. Your goal in finding the domain is to restrict the domain so that it's a continuous function over its domain. So you have to decide, well, which piece do you want? Do you want this piece? Do you want this piece? Do you want this piece? Or whatever. You have to decide based on where your initial condition is. So because my initial condition has an x value of 0, that lies in this range. So then my domain is going to be negative pi over 2 to pi over 2. I know that that may be kind of confusing. The biggest mistake that people make on this test is when they get a question similar to this. They just say that the domain is x cannot equal negative pi over 2, and so on. That's not the goal in stating the domain. The goal is to create a domain that is continuous. So this doesn't make it continuous. It just tells you where the problems are. You need to tell where there's like not a problem. The domain that like it's fine over. If that's confusing to you and you don't get what I'm saying, do your best and we'll go over it next class.